So I am Arpit and he is Dr. Anshu, and we are from Mechatronics and Instrumentation Lab, IIT Indore, and we are here to showcase our technology that we have developed, that is triboelectric based shoe sole for military applications, for defense applications. So this is the shoe sole that we have developed. Now the overall idea behind this comes is, like, we have heard a lot in the market that there are different types of shoe soles that are being used to power up our devices and all, but the overall principle behind it is utilization of piezoelectric materials, which is very effective and very much working, but there are certain challenges to it. The first being that piezoelectric materials are material dependent, that is, not all material will have this piezoelectricity property, and the second one being that there is a lead content that is present, which is a cause that government is banning these or not allowing it because of the lead content. So we have come up with a probable solution to it, that is called triboelectric nanogenerators. So triboelectricity is nothing, it's very simple static charge. As we feel it in our winters, we'll get this shock. So that shock is because of this static charge. So what we are doing is that we are selecting two materials. It can be any material, a material which has a lot of positive charge or has a tendency to gain negative charge, and a material which has a negative charge or lot of tendency to gain positive charge. So once we bring both the materials together and separate it out, we will see the lot amount of energy is being generated. So we'll show it in the video, a live demonstration.
Okay, so this is a triboelectric nanogenerator. So it has two surfaces. One is tribo-positive, that is aluminium, and another is tribo-negative, that is FEP, fluorine-based polymer. So when they came in the contact, the charge transfer takes places, and because of this charge transfer, we will get a current generated through this process. So you can notice our triboelectric nanogenerator as well as the screen also. So once I will press it, so it will generate a single peak, and once I will release it, it will get another peak. So you can also notice that while pressing it, the peak is getting generated, and still I am holding the pressed location, but there is no peak throughout the signal, and once I will release it, again another peak is getting generated. It means that it works on the separation as well as the contact and the separation. Once it will in the contact position, there is no current is getting generated, while once they will start the separating it, slowly the current potential difference is getting generated, and the current will start flowing through the both the substrate. So we are implementing this triboelectric nanogenerator inside the shoes. So complete both in the front as well as the back side, we implemented the triboelectric nanogenerators as well as all the electronics inside this, so that while motion we can harvest the mechanical energy into electrical energy. So whatever electrical energy will be getting generated will store in the form of some storage device, like we can say super capacitor or micro battery or batteries. Then for application purpose, we can power up some micro devices like our GPS location, or we can use some RFIDs and all. So there are different applications.
So we are currently focusing on 3 applications. So that is based on our experience. So on our experience, what we observed was that with the 2 devices, when we walked at a normal speed of 5 kilometers per hour, at which a normal human being walks, for 20 minutes, the overall power that was generated was 250 microwatts. That power was sufficient enough to power up small sensors. So we have focused on 3 targeted applications, especially for military application. The first one being that we put up a very small GPS, micro GPS, which will, based on my walking, will send the signals, and these signals will be taken up. So the soldiers who are going at high altitudes, so if there is an accident, then it will directly give a signal to the substation that no signal is coming because the soldier is not moving. Since the soldier is not moving, so a substation or backup forces can be sent and can be checked upon. The second application being, we want to connect a small micro heater into it. This small micro heater can be charged up with the help of this power energy that is going in there. So this will always create a hot and humid environment inside the shoe, so that the soldier will never have this frostbite. The third application being, to solve this problem of frostbite, even if the energy is not sufficient, there is a concept called microcurrent therapy. Now the microcurrent therapy simply means there is a specific nerve which gets dried up and does not send the neural signal back to the brain. So that is where the frostbite comes. To solve this problem, we have to give a small amount of current to it, a shock kind of thing, which when continuously be given on it, it will always be activated and this problem won't come. So what we are doing is, with the walking of the soldier, we connect a patch on that nerve, and as the soldier walks, that shock will always be hit onto his surface, which won't be sensed, but that nerve will always feel that shock, and so then by that process we will eliminate the frostbite thing. So these are the three probable application. The TRL level is currently 6.
So in addition to these three application, if we will talk about the industrial application, we can implement this in the any industries where operator is coming from through the main gate. So we'll put the receiver at the main gate. So whenever the any operator is coming through the gate, so automatically its attendance will be marked. Apart from that, its location can be traced throughout the industry, so that we can optimize the operator location, and it should not move here and there to avoid the time and delay. So we can improve the time management of the operators.